A spacecraft is heading back to Earth. It's been on a mission in space for over 7 years. And it's bringing back something extraordinary.
This could be a brand new window on the chemistry as the Earth was forming.
These scientists are preparing for a very special guest from outer space. They're practicing every detail of how they'll handle NASA's very first sample return mission from an asteroid.
You can start loading, and then we'll be in the air already, so this will all be autonomous.
We have several teams ready to collect the sample capsule when it lands. We have 4 helicopters staged to retrieve it rapidly.
On September 24th, 2023, NASA's OSIRIS-REx spacecraft is due to reach Earth. It'll be dropping off a capsule containing material from the asteroid Bennu.
The capsule will be monitored by a number of assets, including infrared imaging and tracking. The landing ellipse is generous, and even if it doesn't hit the dead center of that ellipse, there's still plenty of space within the safety zone.
The long wait turns to nervous excitement and anticipation as the days count down to re-entry and landing in the Utah desert. When NASA's OSIRIS-REx mission set out in 2016 to explore the asteroid Bennu, scientists had no idea of the challenge that faced them, nor what wonders lay in store. OSIRIS-REx is the largest sampling mission that NASA has attempted since the Apollo missions. The mission set out to find out what Bennu is made of. The probe has made many observations on site and is heading back with samples in tow for further analysis.
The nature of the universe, the nature of the solar system provides lots and lots of wonders. So this is one of the reasons why we send spacecraft out to these bodies. Yes, we can see them from the ground, we can use telescopes, but actually going and visiting them, exploring them both for science and planetary defense is vitally important.
The asteroid Bennu is a time capsule containing pristine material that's been untouched for 4.5 billion years. It left the asteroid belt millions of years ago and drifted toward the sun.
Asteroid Bennu is interesting because it's one of the blackest objects in the solar system. So we think it's covered with carbon material, organics, the building blocks of life.
It may give clues as to what triggered life on our planet. Because Bennu is a near-Earth asteroid, scientists have other important reasons to study it.
The asteroid Bennu, which is what we think of as quite a small asteroid, just as wide as a number of soccer fields back to back. And it is an Earth-crossing asteroid of a family called the Apollo asteroids. So it is actually a potential future risk to the Earth.
The sun heats one side of the asteroid, turning it into a low-intensity thruster and altering its course by 300 miles a year. Based on ground observations, NASA estimates it has less than 1% chance of hitting our planet. But scientists hope the mission will help them learn more about protecting ourselves if necessary. There are over 1 million asteroids in our solar system, and of those, tens of thousands are deemed near-Earth objects.
They're spread out through our entire solar system, and they're all different from each other. They have this library of information about how our solar system formed. Very, very rich and highly varied, and we're just starting to understand them.
After launch, OSIRIS-REx made a complete revolution of the sun and used Earth's gravity to send it on a trajectory to Bennu. After traveling for months, the spacecraft catches sight of a celestial body only 500 meters across. Bennu.
It's just so exciting to see the fruition of all these years of work, the time it took to develop the concept, build it, test it, launch it, and then finally get there. It's been a long journey, but it's just so fulfilling to finally get data.
When the mission sent its first images back to NASA, the sand they were expecting turned out to be massive, rocky boulders.
The first issue we had was trying to figure out where's the best place and safest place to land.
The OSIRISREx team spent months mapping the asteroid, trying to find a suitable spot to get samples of the surface. In doing so, the spacecraft set 2 Guinness World Records. First, by orbiting the smallest body ever, and second, for the closest orbit of a spacecraft to a planetary body. Finally, the onboard instruments revealed several potential sampling spots. The team chose one of them and named it Nightingale.
One of the things that we saw was that there were actually particles periodically being ejected from Bennu, and that's a very, very interesting scientific event. Is there something to do with the composition of Bennu, what it's made of? Is there maybe water or something else that's driving that? Or is it due to some type of thermal cracking, if you will, and sending particles out?
As ejected rocks sometimes stay in orbit for several hours, their trajectories allowed scientists to model Bennu's gravity field. With OSIRIS-REx's close orbit and onboard instruments, it captured for the first time ever the life cycle of a natural satellite ejecting some material that then returns to the surface.
Scientifically, it's very, very interesting. So again, we would never have seen this from ground-based observations. You can only see them from a spacecraft investigation.
Close examination of Bennu has revealed another surprise. A number of bright rocks scattered across its surface have come from a completely different asteroid. Bennu is a fragment of a much larger celestial body. Some boulders hold mineral deposits that suggest that Bennu's parent body had some kind of thermal water sources, like the hot vents in the depths of our oceans.
So this speaks to the beauty of exploration. It's like wherever we go, we're constantly surprised.
After a year of observing the asteroid from a safe distance in orbit, the probe moves in to obtain a sample. At this time, Bennu is about 200 million miles away from Earth, so when a radio signal is sent, it takes 18 minutes to reach OSIRIS-REx.
And so the round-trip light time, though, is still significant. So you cannot joystick down to the surface, you would crash.
OSIRIS-REx is equipped with an autonomous visual recognition system, which allows it to control its trajectory.
The spacecraft is a computer, it's a robot. It can think for itself and get down to the surface.
Thrusters allow the probe to navigate with the precision of a few inches per second.
The landing sequence, or the touchdown, it's actually a touchdown very quick. It's not so much landing per se. You touch down very quickly and then lift off again. It takes about a few seconds. So you minimize the chances of things going wrong, like tipping over, running into a rock.
It'll now take 18 minutes for proof of success to reach NASA headquarters. Images beamed back to the control room reveal that OSIRIS-REx has gathered a larger sample than they expected and is spewing an excess of flaky asteroid material into space. Ground control has to undertake the highly risky stowage phase, a painstaking process of tucking the sample collection container into a safe position. They must move quickly, as a grain of asteroid dust could obstruct the seal of the metallic cork, and sample material is escaping. After months of orbital surveying and rehearsals, a sample collection was finally made. The probe began its return to Earth in May of 2021.
So the Osiris Rex spacecraft is on an approach towards Earth.
OSIRIS Rex is scheduled to rendezvous with Earth on September 24th, 2023.
4 hours before the capsule would land on the ground, the SampleReturn capsule was released from the spacecraft. The SampleReturn capsule then enters the Earth's atmosphere and slows down with its heat shield, and then lands by parachute on the ground in the Utah desert.
Preparation and training for this momentous event, nearly 20 years in the making, requires many different teams responsible for everything from tracking the capsule to making sure the samples inside are not contaminated.
When the capsule lands on the ground, it's recovered. That's brought into a clean room in Utah at the training range, and the back shell and the heat shield is removed. We have this multi-layer protection of the sample that we can make sure that it doesn't get contaminated by terrestrial stuff.
The capsule will then be flown to a special new clean room at NASA's Johnson Space Center in Texas, in the same building that houses an extensive collection of extraterrestrial materials and samples such as lunar rocks and meteorites.
The canister is then wrapped up and brought to Houston, where that inner capsule is then opened up so we can get access to the actual sample and then look at the individual rocks that we got, and then the real science begins.
The team has been developing special tools to carefully handle the precious particles collected from Bennu's surface, some smaller than a grain of sand.
There are a number of new analysis techniques that will be used, some custom cameras that have been built, the ability to look at the isotopic ratio that tells you something about how that molecule formed in space from what processes.
Even the first look promises new discovery and will help direct further study.
Within a couple days of sample return, that'll give us our first look at what type of rock this is, the type of chemistry coming from a sample that has Bennu's history, which may not be found in other meteorites that we have on Earth. This could be a brand new window on the chemistry of as the Earth was forming.
In addition, a new understanding of asteroids can also help us to better prepare and deflect future impacts with Earth.
Keep in mind that these missions are science missions, but they tell us about the nature of these objects. Right now they're not dangerous, but they could evolve into potentially Earth-crossing orbits and become a hazard later on. But it speaks to the nature of how to operate, how to characterize these objects, learn about these type of objects that may be a threat to Earth in the future.
Initial analysis will take about 2 years. However, the majority of the samples will remain for further research by future generations of scientists.
75% of the sample is then archived for future analysts, so that things that we haven't even thought of can be developed by future generations of scientists, can ask questions that we don't even know enough to ask right now. That's one of the beauties of SampleReturn.
The sample should provide insight into the role that asteroids played in the formation of planets and the delivery of organic material to Earth that may have ultimately led to life.
It's been a lifelong passion to try and understand how things start, how life starts. We're looking at meteorites to understand the early solar system and how that chemistry 4.5 billion years ago tell us about what could have happened on the early Earth.
The OSIRIS Rex mission has already delivered breakthroughs and set records. It imaged an asteroid in space better than we've captured Earth, the Moon, or any other celestial body. Imagine what new secrets the samples will reveal.